welcome back to another week in the Java data structures tutorial. So in this week's videos, we're going to be focusing on TreeSet. So we kind of got off balance a little bit in our topic. So we first talked a little bit about our queue methods, and now in our first video, we're going to talk about TreeSets. So TreeSets are a brand new topic. So the plan is to talk about tree sets, creating a simple tree set in this video, and next video will be about tree set methods. So let's jump right in. A tree set, previously, everything we've worked with have been data types or data structures, right? As in like linked lists, array lists, queues, stacks, all of these have been data types. It's really important to note though, that tree sets are actually not data types, they're a library in Java. So we've worked with libraries before. In the very beginning of Java, you might remember our math library. Well, this is similar. We're going to be using a tree set library. However, the way it acts is very similar to a data type, and that is because it's kind of copying something. It's like implementing a binary search tree. So binary search trees are the real data type, but that is more for our winter and spring more advanced classes. So for now, we're going to be talking about TreeSet, which are simpler versions to help us understand the basics before we move on to binary search trees. However, I did want to show you guys what a binary search tree is because I wanted to show you guys a visual of something that you can see that what our tree set is saving its values like. So this is a binary search tree in Java. I'm not going to go too into details for a binary search tree, but you guys can kind of see the idea. It's in like a tree, right? So the purpose of our tree set is to kind of copy this. So the values will be stored similar to what we just saw, but not exactly. So we are going to be talking more of that. So the tree set, we're moving on from the binary search tree, is part of a sorted set interface, and it kind of used the tree visual to sort things. However, for the sorted set interface, that is just simply means that it's part of this set type thing. It doesn't mean though that later when we start creating our tree sets, it doesn't mean that we're going to be using sorted set all the time. We'll be using different types of sets. In this video, we'll be using set and navigable set. So that's just an example. And one last thing before we start getting into the coding part, our tree sets, what we use them for is you can see that since they store things similar to a tree shape, it can end up storing plenty of values. So there'll be lots of values that are stored. However, this is good. I've noticed I've used however a lot today. I should probably stop. But this is actually good for us because it uses faster access and retrieval time. So what that means is that we store large amounts of data, but it can take it and retrieve it and use it very quickly. So that is like the benefit of tree sets or binary search trees in general. So you guys can kind of see how this sort of comes from a set, sorted set, navigable set, tree set. There's kind of like the little this is like toddler, child, teenager, adult sort of thing. That's a little bit what it's like. So enough of the talking there. We might have a little bit of an idea of what our tree set is. Let's get into the second part of our video, which is creating a simple tree set. So for creating our simple tree set, if you just take a quick look at my picture over here, and I feel like I should pull it up on the PowerPoint, that makes it easier to use. So this is our tree set. We notice, guys, that there really isn't that hard. There's not much hard stuff going on here. The .add function is something we've been using for, I mean, who knows how much, right? We use .add function for our stacks, for our queues, and for our tree sets. So .add is to add the values in. One last thing that I want you to take note of before we start typing is that over here, we use a set interface here, so set, and then the data type, which is a string. TS is a name, so tree set TS equals new tree set, and then the little brackets over there with the parentheses. So that is first using the example of a set. So let's go ahead and create our own. So I can probably close out this binary search tree now, go to Replit and create a new REPL here, and Java and create REPL. All right, so the first thing that we need to do that I forgot to mention is that since TreeSet is a library, we need to import it. But since we are smart now and we're very advanced, we're going to use import java.util.star. Remember, star imports everything in the util package. So that includes quite a bit of things, right? So first things first, set string data type, and then we can call it, I'll just call it TreeSet is equal to new TreeSet brackets, angle brackets, parentheses. I really want to bring to your attention that TreeSet, it's two separate words, and the S is capitalized as well. That small mistakes, lots of consequences. So now that we've created our TreeSet, it's currently empty. And so how do we fix that? We're going to go and add values to it. So we use the .add function to add values to our TreeSet. There we go. So let's go ahead. We say TreeSet.add, and then we're going to add however many values. So let's think. What do we want our TreeSet to be about? I remember a couple of days ago that I was doing it, and then it was like the weirdest things you could think of to get at the grocery store, or not weirdest, but like it's your birthday and you can pick whatever you want and your parents will buy it for you. So what are you getting? Some people said iPad, which is smart, right? It fits in the cart, and small, meaning you can fit a lot of other things, quite expensive, quite useful. Some people said Venus flytraps, which I thought was just hilarious. Like, I mean, I feel bad for their parents who have to buy them this stuff on their birthday. Some people said turtles. I found that pets was a pretty common theme out of everything. A lot of people wanted pets. There were some normal people like Candy, who liked candy, or they liked fried chicken. I remember that. Fried chicken and semicolon. All right, so let me add one more to our TreeSet. Whoopsies. There we go. And what would I get if my parents said I could get anything? Ooh, I'd probably say cake. Right? I mean, I feel like that's such a basic thing, but if you don't tell your parents you want cake, they're not going to get you cake. Right? And I remember very clearly that my parents, sometimes they don't get cake. They'd rather get like yummy food instead of cake, which is kind of sad. I mean, you could never have enough sweets. But yeah, so this is our TreeSet. Easy peasy, right? All we did was use the .add function. And to print it out, just to show you guys really quickly, print out TreeSet, and let's run the code. So let's give it a second to run, and we're going to see that I want you to pay attention to the order. So the order in which I added in my TreeSet, and so this is kind of a new important signal right here, the order in which I add my values. I have iPad first, but in my printed out TreeSet, iPad isn't the first one, cake. Why? Because cake is always your top priority. Just kidding. So iPad is not first. However, if you take a look carefully, try and see if you can find a common pattern out of everything here. See if you can find a common pattern. And if you can't, I'm going to make your life easier and help you. Say we also want apple pie. At the same time, we also want banana pudding. And last but not least, actually, no, I think we're good like that. These two values, I'm going to run my code again, take another look and see if you can find the similarities or differences, or like just what is happening? What is the pattern in the order here? We get apple pie, banana pudding, cake, candy, fried chicken. Well, this is sorted alphabetically, right? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, and then V. So we know that our TreeSets are sorted alphabetically. I do want to emphasize here, though, that alphabetically is in usual circumstances, so unless otherwise stated. So what I mean by that is that the standard, if you don't tell your TreeSet how to sort your items, then they will sort you alphabetically. Now, obviously, if you tell your TreeSet to sort it in one particular way, it's going to do that. But the standard automatic is alphabetical. So that's what it is. I want to do one last test with you guys, and I want to show you guys this. Say I'm really greedy that day. Well, not I'm greedy. Every kid has a right to do some things they wouldn't do on their usual days on their birthday. So I want to buy 2 iPads. And I also am just so hungry that day. I want to buy 2 cakes because I really need the sugar high to kick in. So I've added iPad twice and I've added cake twice here. Do we think that these 2 values are going to get added into our tree sets? So will we have 2 iPads and 2 cakes? Well, let's go ahead and run it and see. So most people think yes, that it'll be added twice. But if you take a look at our printed tree set, it's actually only added once. So this brings us to a new concept to understand. And I'm going to bring this up here. And then we'll just say down here that the tree set will automatically delete duplicates. So I don't know how to phrase this, but I'm going to explain it to you. So when it's looking at this, before it even adds these values, adds the second iPad to the tree set, when it notices that it's a duplicate, this value is not even going to get added into your tree set. So it's not even added. When it sees that it's a duplicate, it's not added. So basically, I should probably rephrase this. The tree set will not add duplicates to itself. Will not add duplicates. There we go. Good. So to sum up this video, we talked about what the tree set was. We learned that it implements or is trying to copy something like a binary search tree. It's good for storing large amounts of data. And oh, one last thing I want to point out. We used set the entire time here. Next video, we will be using a different name. It will not be set, but we use set here. Tree set do not add duplicates. You cannot have duplicates, and then they're sorted alphabetically unless otherwise specified. So that's it for this first video. I hope you guys understood it and had some fun adding things to your own tree set. We'll be back for the next video to learn about some tree set methods. I will see you guys then. Bye, guys.